Hey guys, how's it going? So today we're going to do a bit of calculus too, and we're going to do two specific problems. Here's the first problem. So imagine we have a circle here. It looks something like this. We have 0, 1, this is a circle, and then 2, 2 x, and that's y. That's considered 1, -1. And the shape of this is actually, you know what, I'm not gonna do it like this because there's more to it. So the equation of this circle is x minus 1 squared plus y squared is equal to 1. And I mean, you can kind of tell that this is the correct shape because the center is at 1, 0, 1, and then y, this is equivalent to y minus 0 squared. So the center is at 1, 0, and has a radius of 1. So this is the shape. And now let's say we had two lines passing through it. Let's say we had two lines. One line looks at something like this, and one line looks something like this. And this would be y is equal to root 3x. And y is equal to 1 over root 3x. Now the question is, can we solve this part, this area that I'm shading in right now, A, using polar coordinates? How do we do this? First of all, you should be able to recognize that this is a very good question. To do it, recognize that x is equal to r cos theta. This is just a transformation into the polar coordinates. Always, x always equals r cos theta, and y always equal r sine theta. It's a nice, and when you think about it, it's actually a nice little connection, because remember how in a Pythagorean theorem, you have something like x squared plus y squared is r squared. Like, this is not part of the question, but I'm trying to, this is the right angle. You have x and y and r. And then, yeah, x squared plus y squared is r squared. Okay, so then that would be r squared cos squared theta plus r squared sine squared theta is r squared. You could factor out r squared, and then you realize that because sine squared theta plus cos squared theta is 1. So this is the way you would do it in polar coordinates. Just in case you were curious as to why these two were the case. Anyways, back to solving the problem. So let's focus on the lines first. Y is equal to root 3x. Okay, so we should just directly substitute this in. R sine theta is equal to root 3 r cos theta. R cannot be 0, so it's safe to divide everything by r cos theta. And when you do that, you're left with tan theta is equal to the square root of 3. Well, if you were to picture this, we're in the first quadrant here. So only focus from 0 to pi over 2. Theta is pi over 3. Okay, so how about y equals 1 over root 3x? Okay, so you do the same thing. R sine theta equals 1 over root 3 oh my God, I'm so sorry about the way I drew that. Is 1 over root 3 r cos theta. Okay, divide both sides by r cos theta, you're left with tan theta equals 1 over root 3. And then theta is pi over 6. So this is the way, think of it like this is straight line. It looks like an angle, pi over 3 and pi over 6. Pi over 6, that's pi over 3. Okay, so we've broken them down into 2 lines. Let's try to make this circle into polar coordinates. So then in that case, it's r cosine theta minus 1 squared plus r squared sine squared theta. Oh my God. Equals 1. Oh, this pain. This pen, sorry. Okay, then you do this. Just expand it. R squared cos squared theta minus 2r cos theta plus 1 plus r squared sine squared theta equals 1. 1 and 1 cancel out here. R squared cos squared theta plus r squared sine squared theta is just equal to r squared minus 2r cos theta is equal to 0. Divide both sides by r. I told you r cannot be 0. So r simply equals 2 cos theta. And there's actually a very nice connection in polar coordinates between finding the area using polar coordinates. And here it is. The formula is A for area is equal to theta 1, the integral from theta 2 to theta 1, theta 1 to theta 2, sorry. And it would be, let me think, 1 over 2 and r of theta squared, r of theta squared like this, the entire function squared, not just theta itself, d theta. Let's apply that. A is now equal to, let's see, so that would be pi over 3 and pi over 6, right? Yeah. Pi over 3, pi over 6. And 1 over 2, r of theta squared. 2 cos theta squared is 4 cos squared theta. D theta. equal to 2. I just 4 divided by 2, yeah. Pi over 3, pi over 6. I think 2. So cos theta is 1 plus 2 cos plus cos of 2 theta. Divided by 2 d theta. That's equal to 2's cancel out. Um, 1 plus cos 2 theta. E theta. And this, when you find the antiderivative, theta plus 1 over 2 sine 2 theta pi over 3 pi over 6. And when you break this out, it's just equal to pi over 6. And that's the question done. So the second thing I wanted to do for calculus 2 was something about parametric equations, but that video would be too long if I did that. So I think I'm going to stop here, and I'm going to post that second part of calculus 2 tomorrow or Wednesday. But yeah, hope you guys found this video helpful. If you have any questions, be sure to shoot me an email at brentwayne11@gmail.com. Or comment on my YouTube, see what more stuff do you want to see. But yeah, for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.